Hello. Now that you know how to simplify radical expressions, we can use that skill to add and subtract radicals. And that is what we will be doing in this lesson. In order to add and subtract radicals, we first simplify radical expressions and then combine like terms. Now, what are like terms in radical expressions? Well, look at this. 2 square root 6 minus 1 square root 6. Well, this is 1 square root 6, is that right? Just like we say 2x minus x equal to x. 2 square root 6 minus square root 6 will be 1 square root 6. Right? So just like 2x minus x equal to x, we can say 2 square root 6 minus square root 6 is 1 square root 6. And of course we don't write that 1. So you understand what like terms are in radicals. 3 square root 2 can be added to 5 square root 2. They are like terms. But can you do 5 square root 3? Can you add that to 2 square root 2? No. It's like adding 5y to 2x. They are unlike terms. Okay, let's have a look at another one. 5 square root 2 plus 7 square root 2 minus 11. What are the like terms here? The like terms here are the terms in square root 2. 5 square root 2 can be added to 7 square root 2. They are like terms. So what do you get if you add 5 square root 2 to 7 square root 2? It is 12 square root 2. And of course the minus 11 will stay on its own. So the answer there is 12 square root 2 minus 11. Add like terms to simplify radical expressions. Another one. 6 cube root of 5 minus 8 cube root of 5. Are they like terms? Yes, it is like 6p minus 8p. So what is the answer? 6 cube root 5 minus 8 cube root 5 is negative 2 cube root 5. Another one. 3 cube root of a plus 7 plus 5 cube root a minus 6. Now how would you pick the like terms here? Terms that contains cube root of a are like terms, and then the numbers are like terms. So first of all, we combine like terms. Look at the way I pick the like terms. 7 minus 6, I'll write that first, plus 3 cube root a plus 5 cube root a. Alright, now what is 7 minus 6? 7 minus 6 is 1, and 3 cube root a plus 5 cube root a is 8 cube root a. Okay, let's do another one. 3 square root a, so always look at the type of radical. 3 square root a plus 4 cube root b plus 2 square root a minus 12 cube root b. Okay, what are the like terms that we can combine? 3 square root a and 2 square root a are like terms. Similarly, 4 cube root b minus 12 cube root b are like terms. I have used colors there to represent the like terms. So we can add 3 square root a to 2 square root a, and then we add 4 cube root b to minus 12 cube root b. What is the result? 3 square root a added to 2 square root a will be 5 square root a, and 4 cube root b minus 12 cube root b is minus 8 cube root b. In other words, what all you need to look at are the coefficients. Here, the coefficient is 4, and the coefficient of this term is 4. The coefficient of the last term is negative 12. 4 minus 12 is negative 8. Okay, let's move on to another one. Simplify square root 75 plus square root 108. Well, we talked about this in the last lesson. If you want to simplify a square root quantity like this, what is the first thing we need to do? We need to write the number inside the square root as the product of the biggest perfect square. Why? Because it is a square root. Biggest perfect square and another number. Alright, can you tell me 75? What is the biggest perfect square in 75? We have actually done that 3 or 4 times in the last class. The biggest perfect square in 75 is 25. So we write 75 as 25 times 3. Alright, let's see if anybody can figure this out. 108. What is the biggest perfect square in 108? Well, that's a little tricky, is that right? Well, I can tell you, but you need to learn this. 36 multiplied by 3 is 108. 36 is a perfect square. Is that right? 6 times 6 is 36. Alright, so we do that. Write the numbers inside the radicals as product of perfect squares. Square root 75. Square root 75 is square root of 25 times 3. You can see I have used 25 in red, indicating that that is a perfect square. And square root 108 is square root of 36 times 3. What is the next step? Each of these radicals now can be split into 2 pieces. Square root of 25 times 3, we write it as square root 25 times square root 3. There you are. And square root 36 times 3 is square root 36 times square root 3. Okay, now you know square root 25 is 5 and square root 36 is 6. We do that in the next step. So this will be now 5 square root 3 plus 6 square root 3. Well, you notice that they are like terms, we can add them. So that will be now 11 square root 3. Now, these kind of simplifications are very important and you must be very familiar with it. Okay, let's try another one. 3 square root 250 plus 5 square root 160. Well, anybody tell me what is the biggest perfect square in 250? Well, 250 can be written as 50 times 5, but that is no use for us. Why? 50 is not a perfect square, 5 is not a perfect square. Well, how else can I write 250? I can write 250 as 125 times 2, but none of them is a perfect square. Well, 250 is 25 times 10, right? 25 is a perfect square. You see, once you obtain one of them, in other words, this, if you can say, you're going to write it as 25 times 10. where 25 is the perfect square and 10 is not the perfect square. You would expect a 10 in the second one also, because we are expecting to add them. We need to produce like terms. So if you have a 10 in the first quantity, which is not a perfect square, we would expect the same thing in the second also. And therefore, how do we write 160 as the product of a perfect square? 160 will be 16 multiplied by 10. So 250 is 25 multiplied by 10, and 160 is 16 multiplied by 10. Let's write that. So write each of the numbers inside the radical using highest perfect square. This, the first term now become 3 times square root of 250, the square root of 25 times 10, plus 5 times square root 160 is square root of 16 times 10. You notice the 10 that appears in both, that's a clue. Once you see that happens in the first number, you must expect the same thing in the second number. Alright, how do we simplify this? Write the quantity inside the radical as the product of 2 radicals. This will be written as square root 25 times square root 10. And this radical will be written as square root 16 times square root 10. Let's write that. That is 3 times square root 5 times square root 10 plus 5 times square root 16 times square root 10. In the next step, we know square root 25 is 5. That's the reason why we wrote it like that. Is that right? And square root 16 is 4. Let's write that in the next step. That will be 3 times 5 times square root 10 plus 5 times 4 times square root 10. In the next step, we know we can multiply these numbers. 3 times 5 is 15. So your first term is 15 square root 10 plus the second term is 5 times 4 is 20. That will be 20 square root 10. Alright, that will be 15 square root 10 plus 20 square root 10. They are like terms, we can add them. That will be 35 square root 10 is the answer. Isn't that a good problem? And a very important type of problem. Let's go and do another one. 3 square root 40 x squared y plus 2x square root 40 490 y. We will leave the terms outside the square root as they are. We will concentrate on simplifying what is inside the square root. That is the first thing to do. So, we write each number inside the square root or inside the radical sign as product of the highest perfect square. Okay, can we start talking about it? 40. Can you write that as the product of a perfect square and a number? I know most of you will tell me 40 is 8 times 5, but 8 is not a perfect square, 5 is not a perfect square. So what is it that you're going to write 40 as? 40 is 4 times 10. 4 is the highest perfect square in 40. So 40 is going to be 4 times 10. What will then 490 be? The clue is there. If this is going to be written as 4 times 10, 490 will be 49 times 10. Okay, so we have now dealt with 40 and 490. How about x squared? Well, x squared is a perfect square. We don't need to do anything there. Alright? So, look at the way I'm going to write it. This is 3 times square root 40 x squared y is written as square root of 4 times 10 times x squared times y. And you noticed I have used red color for 4 and x squared. Why? Because they are both perfect squares. 10y is not a perfect square. Come to the second term, is 2x times square root of 490, I wrote as 49 times 10, and of course the y will stay as y. In our next step, we will separate the perfect square radicals, and that will be, you can see I have started from here, that will be 3 times, I have put 4x squared together in one square root. Why? Because 4 is a perfect square, x squared is a perfect square. I can combine both together in one radical, and those that are not perfect square will remain in another radical. I hope you understand that. 4x squared is separated and put under one radical, and 10y is now under a separate radical, plus 2x times 49 is the perfect square, that is separated into one radical, times square root 10y is in the next one. Okay, in the next step, anybody tell me what is square root of 4x squared? Take the square root of each of these. What is square root of 4? Square root of 4 is 2. What is square root of x squared? Square root of x squared is x. So square root of 4x squared is 2x. This will be now 3 times 2x times square root 10y plus 2x times square root 49 is 7 times square root 10y. And now we multiply the quantities outside the radical sign. 3 times 2x is 6x. 2x times 7 is 14x. Let's do that in the next step. That will be 3 times 2x is 6x times square root 10y plus 2x times 7 is 14x times square root 10y. And now you notice these are like terms. Now, what makes them like terms? Look at the first one, x square root 10y, you see, and x square root 10y. There are 6 of those here. 6x square root 10y added to 14x square root 10y. They are both like terms. Therefore, we can add them. On the other hand, instead of an x, if you had a y here, we will not be able to add them. We are able to add them because this x square root 10y is exactly the same as x square root 10y. There are 6 of those in the first term and 14 of those in the second term. We can add them together. Just like 6 tables added to 14 tables gives you 20 tables. We have 6x square root 10y plus 14x square root 10y gives us 20x square root 10y. Okay? Alright, that has been a very good one. Let's now look at another one. Simplify 5 square root 8 plus 2 square root 50 minus 3 square root 72. Where there are no x or y in there, under the radical we have these numbers. Can you write those numbers? as product of their highest perfect square. Always look for the type of radical. They are square root, and therefore we look for the perfect squares. Alright, what is the highest perfect square in 8? That's simple. That's 4 times 2. 8 is 4 times 2. You see, once you do 1, you get the clue. What is the clue? In the first number, the perfect square is 4 and the remaining number is 2. That means we would expect the remaining number to be 2 in the second and also the third radical. That's the clue. Alright, so if 8 is 4 times 2, what will then be 50? What is the highest perfect square in 50? 50 is 25 times 2. See, look at the 2 coming there again. Alright, 72. What is the highest perfect square in 72? Yes, it is 36. 72 is 36 times 2. Look at the clue there. In each of these, the number that is not the perfect square is 2. 8 is 4 times 2. 50 is 25 times 2. 72 is 36 times 2. Alright, let's write that. So this now equal to 5 times square root 8 is square root of 4 times 2. Square root 50 is square root of 25 times 2. And square root 72 is square root of 36 times 2. Okay, now what is the next step? Next step is to separate these radicals into 2 separate radicals. Square root 4 times 2 will be square root 4 times square root 2. Square root 25 times 2 is square root 25 times square root 2. And square root 36 times 2 will be square root 36 times square root 2. There you are. So I simplified each of these terms. Watch it again. 5 times square root 4 times square root 2 plus 2 times square root 25 times square root 2 minus 3 times square root 36 times square root 2. Alright, so far? You can now do the next step. What is the next step? Square root 4 is 2. Square root 25 is 5. Square root 36 is 6. That's our next step. So that will be 5 times 2 times square root 2 plus 2 times 5 times square root 2 minus 3 times 6 times square root 2. Now we can multiply these numbers, can't we? That will be 10 square root 2 plus 10 square root 2 minus 3 times 6 is 18 square root 2. So 10 square root 2 plus 10 square root 2 minus 18 square root 2. They are all now like terms. We can add them. 10 square root 2 plus 10 square root 2 is 20 square root 2 minus 18 square root 2 is 2 square root 2. So that will be 20 square root 2, the sum of these two, minus 18 square root 2. You can see 20 minus 18 is 2. Therefore, 20 square root 2 minus 18 square root 2 is 2 square root 2. That was a beautiful problem. Alright, practice that one more time. Let's go for the next one. And look at the radical here. This time we have a cube root. 4 cube root 5 minus 5 cube root 40. So if you want to simplify a cube root expression, then the number inside the cube root needs to be written as the product of a perfect cube. Do you remember some of the perfect cubes we talked about? Review that. The first perfect cube we talked about is 2 cube. What is 2 cube? It's 8. 8 is a perfect cube. Why? Because we can take the cube root of 8. What is cube root of 8? Is 2. The next perfect cube is 27. 3 cube is 27. Cube root of 27 is 3. What is the next perfect power of 3? Is 64. Perfect cube, perfect power of 3 is 64. 4 cube is 64. Therefore, cube root of 64 is 4. Okay, let's come over here. The first number in the first radical is 5. Is it possible to write 5 as the product of a perfect cube? No. So we leave it like that. That cannot be further simplified. Let's go to the second cube root. Cube root of 40. Can you write 40 as the product of a perfect cube? Well, we know 8 is the first perfect cube that we talked about. 40 is 8 times 5. So write 40 as the product of a perfect cube. 40 is 8 times 5. Therefore, 4 cube root 5 minus 5 cube root 40 can now be written as 4 cube root 5, that will not change, minus 5 times cube root of 8 times 5. What is our next step? Split this cube root into 2 pieces. It will be cube root of 8 times cube root of 5. So the first will not change. 4 cube root 5 minus 5 times cube root of 8 times cube root of 5. What is our next step? Simplify cube root of 8. What is cube root of 8? Is 2. So that will be the second term is minus 5 times 2 times cube root of 5. You notice we have cube root of 5 in both terms. Look at that clue again. Okay, this will now be 4 cube root 5 minus 5 times 2 is 10 cube root 5. They are now like terms. 4 cube root 5 minus 10 cube root 5 is what? Is negative 6 cube root 5, and that is the answer. So before you simplify radical expressions, always look for the type of radical. If it is a square root, then we will be looking for perfect squares. If it is a cube root, we will be looking for perfect cubes. Okay, let's go and do another one. Look at the first one, square root. 3 square root 27 c squared minus 2 square root 108 c squared minus 48 c squared. If you look at the quantities inside the radical, c squared, c squared, c squared. C squared is a perfect square. So we don't need to do anything with the c squared. That is a perfect square. We can actually bring it out. Let's look at the numbers. 27, 108, 48. Now your task is to write each of these numbers as the product of a perfect what? Perfect square, because we are dealing with square root. Tell me, what is the biggest perfect square in 27? the biggest perfect square in 27? Well, 27 is 9 times 3. 9 is the perfect square. And 3 is not a perfect square. So, we will write 27 as 9 times 3. Look at the 3 there. You would expect the 3 to come in the second number also. Tell me, what will therefore be 108? Can you write 108 as the product of a perfect square? We have done that in the last but one problem. 108 is 36 times 3. Look at the 3 again there. So 27 is 9 times 3. 108 is 36 times 3. Tell me, how will you write 48 as the product of a perfect square? You should now be able to tell me this. 48 is, alright, did I hear anything? Yes, it is 16 times 3. 48 is 16 times 3. Alright, we look for perfect squares inside the radical. So, we are now going to write 27 as 9 times 3, 108 as 36 times 3, and 48 as 16 times 3. And that's what I have done in this step. And what is our next step? Separate each radical into two pieces. One that contains the perfect square, and the other that contains the one that is not the perfect square. So this will be split as square root of 3 times square root of 9c squared. And this radical will be split as square root 3 times square root of 36c squared. And this will be split as square root 3 times square root 16c squared. Well, I wrote the perfect square quantities first. So look at that again. This is equal to 3 outside, and square root 3 times 9c squared is written as square root of 9c squared times square root of 3 minus 2 times square root of 36c squared times square root of 3 minus square root of 16c squared times square root of 3. Each radical is split so that you have the perfect squares inside one radical and the one that is not the perfect square in another radical. And now we simplify each of the radicals that contains the perfect square. Tell me now, what is square root of 9c squared? Square root of 9 is 3. Square root of c squared is c. Okay? And what is square root of 36c squared? Square root of 36 is 6. And square root of c squared is c. Alright, let's go to the last one. What is square root of 16c squared? Square root 16 is 4. And square root c squared is c. So, in our next step we have 3 times square root of 9c squared is 3c times the square root 3 minus 2 times square root 36c squared is 6c, there we are, times that square root 3 minus square root 16c squared is 4c times that square root 3. Now we multiply each of these numbers. 3 times 3c is 9c. 2 times 6c is 12c. Alright, let's do that. That will be 9c square root 3 minus 12c square root 3 minus 4c square root 3 Tell me, are they all like terms? Well, apparently they are. All these terms contain c square root 3. Look at this, 9c square root 3 minus 12c square root 3 minus 4c square root 3. So what all we need to do is to add their coefficients. 9, negative 12 and negative 4. Well, can you do that? Add the negative ones first. Negative 12 minus 4 is negative 16. Negative 16 added to positive 9 is negative 7. So this will be negative 7c square root 3. Alright? Okay, let's go and do another one. This time 3 square root 45x cubed plus square root 5x. Well, we have a square root. That means we are looking for perfect squares. What is the first step? Look for perfect squares inside the radical sign. Let's look at the first radical sign. The number is 45. Can you write 45 as the product of a perfect square? What is the highest perfect square in 45? 45 is 9 times 5. Okay, so we will write 45 as 9 times 5. How about x cubed? X cubed is not a perfect square. Why not? Because the power is odd. You see, in order that a power may be a perfect square, the power has to be even. X to the power of 4 is a perfect square. X to the power of 6 is a perfect square. X to the power of 2 is a perfect square. So can you write x cubed as the product of a perfect square? Yes, it is. X cubed will be written as x squared times x. X squared is a perfect square. Okay, let's do that. Now, 3 times square root 45 x cubed. Look at the way I wrote 45. 45 I wrote 5 times 9. And x cubed is written as x squared times x. Why have I colored 9 and x squared red? Because both 9 and x squared are perfect squares. We are going to pull them out and put them separately in a radical. And 5x is not, which is going to remain in another radical. So in our next step, we're going to pull out the 9x squared, which is the perfect square, in a separate radical, and 5x will remain in another radical. So once again, square root of 5 times 9x squared times x is square root of 9x squared times square root of 5x. Alright? And the last term, square root 5x, will remain as it is because you cannot do anything with 5 or x. Now we simplify square root 9x squared. What is square root 9x squared? Is 3x. So the first term is 3 times 3x times square root 5x plus square root 5x. Multiply these. 3 times 3x is 9x. So this is 9x square root 5x plus square root 5x. Tell me, are these like terms? Don't get confused when you see the square root 5x in both. They are not like terms. You cannot add them. Why not? Because the first term is 9x square root 5x. The second term is only square root 5x. They are not like terms. If I had an x here also, then they would have been like terms. So x square root 5x and square root 5x are not like terms. The only thing we can do here is square root of 5x is a common factor which you can factor out. So I have factored out the square root 5x. What is left in the first term is 9x plus what is left in the second term is 1. So we write it as square root 5x as the common factor times 9x plus 1. Okay, so I hope you understand why these two terms are not like terms. Okay, let's do another one. What is it that you see here first? You must see, first of all, each of the radicals is a cube root, and therefore we look for perfect cubes inside the radical. Can you help me write each of the terms inside the radicals as the product of a perfect cube? Okay, let's start with this. 27. Can you write 27 as the product of a perfect cube? Well, isn't 27 a perfect cube by itself? Yes, 27 is 3 cubed. So 27 is a perfect cube. We will leave it as such. How about x to the power 5? What is the highest perfect cube in x to the power 5? You see, a power becomes a perfect cube when the power can be divided by 3. For example, x to the power of 3 is a perfect cube. What is the next perfect cube? X to the power of 6. X to the power of 9 is a perfect cube. X to the power of 12 is a perfect cube. If a power has to be a perfect cube, then the power, we should be able to divide the power by 3. Can you therefore write x to the power of 5 as the product of a perfect cube multiplied by something else? Yes? X cubed and x to the power of 5 can be written as x to the power of 3 multiplied by x to the power of 2. Is that right? Yes, it can be. So x to the power of 5 equal to x to the power of 3 times x to the power of 2. You know, when you multiply the same base, you add. 3 plus 2 is 5. Now, x to the power of 3 is a perfect cube. Why? Because 3 can be divided by 3. So, in here, 27 is a perfect cube. X to the power of 5 will be written as x cubed times x squared. Okay, let's now go to the second radical here. X squared, y squared. Now, can you write x squared, y squared as the product of a perfect cube? No, you cannot, because the simplest perfect cube is x cubed. The simplest perfect cube is y cubed. So x squared, y squared cannot be written using perfect cube. We will leave it like that. Let's now go to the third one. Cube root of x to the 8 y squared. Can you write x to the power of 8 as the product of a perfect cube like we did here? Knowing that a perfect cube, the power can be divided by 3. So, tell me, what is the highest perfect cube in x to the power of 8? Well, I hope some of you will get it. x to the power of 8 can be written as x to the power of 6 multiplied by x to the power of 2, isn't it? X to the power of 8 is x to the power of 6 times x to the power of 2. X to the power of 6 is a perfect cube. Why? Because 6 can be divided by 3. Okay, this is what we're going to do in the next step. Alright? So, I left 27 as it is in the first radical and colored in red. It is a perfect cube. X to the power of 5 is written as x squared times x cubed. X cubed is a perfect cube. And y squared will be left as such. Minus x squared times the second radical will stay as it is, x squared y squared, because there are no perfect cubes in it. Plus 2 cube root of x to the 8 is written as x to the power of 6 times x squared, and y squared will remain as such. In our next step, each radical will now be split into two, one containing the perfect cube and the other containing the not perfect cube, right? Okay, so this will be cube root of 27 x cube is separated out, leaving a cube root of x squared y squared. So this is split into two as cube root of 27 x cube times cube root of x squared y squared minus x squared times, we can't do anything with it, we leave it as such, plus 2 times cube root of x to the 6 is separated out times cube root of x squared y squared will stay together. And now we will do one more thing. We simplify the cube root terms. What is cube root of 27x cubed? You should be able to tell me that. The cube root of 27 is 3. Cube root of x cubed is, remember to find the cube root of a power, all you need to do is divide that power by 3. So x to the power of 3 divided by 3 is 1. That is x to the power of 1. Cube root of x cubed is x. So this becomes 3x. Cube root of 27x cubed is 3x. Alright, next we will do this. What is cube root of x to the power of 6? Again, how do we find the cube root of a power? Divide the power by 3. So this will be x to the power of 6 divided by 3, which is x squared. Okay, so let's write that. That will be x times 3x times cube root x squared y squared minus x squared times cube root x squared y squared plus 2 times cube root x to the 6 is x squared times cube root x squared y squared. Now look at the way we neatly obtain cube root x squared y squared in every term. One more simplification. Our first term is x times 3x, which is 3x squared. Alright, so this will be 3x squared cube root x squared y squared minus x squared cube root x squared y squared plus 2x squared cube root x squared y squared. Tell me, are these like terms? Are they like terms? Yes, indeed, they are. Look at this. X squared cube root x squared y squared, x squared cube root x squared y squared, x squared cube root x squared y squared. They are all the same. They are similar. They are like terms. So what all we need to do is add their coefficients. The coefficient of the first term is 3. The coefficient of the second term is -1. The coefficient of the third term is 2. That will be 3 minus 1 plus 2. What is that? 3 plus 2 is 5. 5 minus 1 is 4. So this will give you 4 what? 4x squared cube root x squared y squared. And that is the answer. Okay? I think this is a very good one. And I think you need to practice that one more time. Alright, let's now do another one. Multiply and simplify cube root of 2 times cube root of 4. Now, if you look at the properties of radicals we discussed earlier, square root A times square root B is the same as square root of A times B. Similarly, cube root of A times cube root of B is cube root of A times B. Can you use that property here? Cube root 2 multiplied by cube root 4 can be written as cube root of 2 times 4. Why not? So we combine this as one radical. Cube root 2 times cube root 4 is cube root of 2 times 4. What is the incentive in doing this? You see, you must have some understanding of this in order to decide what to do. Well, you know that 2 times 4 is 8. And 8 is a perfect cube. Is that right? You can find the cube root of that. And that is the incentive. So cube root 2 times cube root 4 is cube root of 2 times 4, which is cube root of 8. And what is cube root of 8? Is 2, because 8 is 2 cubed. Alright, a very simple expression, but you need to have that understanding to do these kind of problems. Well, I think we have actually spent quite an amount of time simplifying radical expressions and then using that understanding to add and subtract radical expressions. So what have we done so far in this unit? In this unit, we had a general discussion on radical expressions. Then we discussed how to simplify radical expressions. And in this lesson, we saw how to add and subtract radical expressions. What is remaining is the skill of multiplying and dividing radical expressions. And we have 2 more lessons in this unit, and they will be dealt with in those lessons. Alright, I'll see you for the next lesson a little later. Bye.